Hi everyone. In this video, we are going to consider the conditional probability. So, it is calculating the probability keeping some conditions or keeping some restrictions. So, we shall see what is conditional probability. The probability of an event A represents the likelihood that a random experiment will result in an outcome in a set A relative to the sample space S. Yes. So, in a simple case, the probability of an event A without any restriction shows how likely that event will happen in a random experiment which has a sample space. So, without any restriction, that is what the probability of an event A shows. That is a likelihood. Now, if we have some prior information about the outcome of a random experiment, then we must use that prior information for our calculation of the probability of the event A. So, if we have prior information that the outcome of the random experiment must be in a set B of the sample space, then we have to consider this set B specially. So, considering this prior information to our problem, considering this prior information or incorporating this prior information to our problem is what is called the conditional probability, or making use of this prior information for our problem is what we are going to do in a conditional probability. So the conditional probability is incorporating the prior information which is denoted by probability of A given B. So probability of, this is read as probability of A given B. Instead, when we were calculating just probability of A without any conditions, it was written probability of just A, P of A. And now we have a prior information, and when that prior information is also added to our problem, and we have to find the probability of A given B. So it is denoted by probability of A given B. Okay, so now we shall see some examples of the conditional probability. So let us consider a random experiment of drawing a card from a pack of cards. So we are going to consider an example of drawing a pack of cards, drawing a card from a pack of cards. That is, we are going to consider the playing cards. And the probability of happening of the event A, or the probability of happening of event A has to be calculated, and that event A is defined as the card drawn as a king. So we need to know what is the probability of drawing a king from a pack of cards. So from a deck of cards we know there are only 4 kings, that is of 4 simples and of 2 colors, isn't it? Yes, we have 4 kings. So since we have 4 kings and in a deck of cards there are 52 cards, we will get the probability of the event A as 4 by 52, which is equal to 1 by 13. Now suppose there is another information that we have to find the probability that it is a king, that the drawn card will be a king, but there is some information that suppose that drawn card is a red card. So there is another information that drawn card is a red card. So we can consider this information as event B. So if the event B is such that the drawn card is red, then we have to incorporate this information to our problem. That is, we have to incorporate this information to the event A. So then we can compute the probability of A given B, that is B that the card drawn is red, that is a given information, and we have to find the probability that the card drawn is a king. So it can be written as n of A intersection B divided by n of B. We have told if we have a given information, we shall reduce our sample space to that one. We shall cut down, or we shall only concentrate on that subset. So here in the denominator, instead of this n of S, we have n of B. That means we know there are only 26 cards that are red and the rest 26 are black. So n of B is 26 and n of A intersection B. We know A is the event of the card drawn as a king and B is the event that the card drawn is a red card. So there are only 2 red kings, therefore n of A intersection B will be 2. So there we get probability of A given B as 2 by 26, which is equal to 1 by 30. So in this case, you can see that probability of A and probability of A given B have the same value. But this need not be true always, because probability of A and probability of A given B are not always same. It is different. So we shall consider another example. This example is a little more familiar one, where we are going to toss 3 fair coins. So while tossing 3 fair coins, we know our outcome will be HHH, HHT, HTH, THH, THT, TTH and TTT. That means in each tossing of a coin, there is a possibility of a head and a tail. So, in simultaneous tossing of 3 coins, the possibilities are, there are 8 possibilities, and those possibilities are given here, which I have already told. So, I am going to denote all these outcomes, or all these possible outcomes in terms of W1, W2, etc., W8. Now, that is for the ease of writing, and probability of WA is equal to 1 by 8 because it's a random experiment of tossing 3 fair coins. Therefore, each outcome has equal probability of happening. Now, the thing is that this is a simple coin tossing experiment, isn't it? Yes. So, suppose that the same experiment is repeated by another person. So, it can be done by any number of people. So, suppose that the same experiment is repeated by another person and nothing is known about the outcome. We don't know what the outcome is. Outcome is not known to us. But we have some information that he obtained at least 2 hits. Suppose we have an information that he or he had obtained at least 2 hits. So, if it is at least 2 hits, then what are the possible outcomes? It could be either all 3 could be head, or there could be HHT, HTH or THH, because in all those outcomes there must be at least 2 heads. The third one can be anything, either a head or a tail. Now, we can say the event A as at least 2 heads are obtained. So, we need to find the probability of at least 2 hits are obtained, and there is something more. Then the possible outcomes. Then the possible outcomes are W1, W2, W3 and W4, isn't it? Yes, we have already told those are W1, W2, W3 and W4. Now, what will be the probability of W1 given A? Probability of W1 given A will be equal to probability of W2 given A, and will be equal to W3 given A, and will be equal to probability of W4 given A, which is equal to 1 by 4. Why? When there was such a restriction that at least 2 hits are obtained, all those outcomes were trimmed and we have only a very few outcomes in our subset. That is, the total sample space has been cut into 2, where we have only 4 four outcomes in that set. So that are W1, W2, W3 and W4. So for happening of an event among this set is all those has equal probability, and that probability is 1 by 4. So you can see that here in the first case, when it was probability of Wi, it was 1 by 8. That means in the normal case, all those event outcomes had equal probability of happening, and that was equally likely. And when there was a condition that at least two heads are obtained, if that when that information was given, when that the event A was given, probability of W1 given A is equal will be 1 by 4, and for all probability of Wi for I equal to 1 to 4 is 1 by 4. So here you can see that probability of Wi and probability of Wi given A are not equal. So when we have an information with us, that makes a difference. Thank you.